Hi, my name is Alexander Knopp, and this is Introduction to Combinatorics. In the previous videos, we discussed how to compare sizes of sets, how to find in simple cases their sizes. In this video, we continue going in this direction, and we are going to discuss how to compute sizes of the sets and how to prove some kind of equalities about these sizes. The first question we may discuss is how many functions f from the set of n elements to the set of m elements. Okay? So informally, it's very easy. We need to assign an element to the first element of this set, and there are m variants to do this. So for the second element, there are m more cases because we may use any element of the image. And by the multiplicative law, we need to multiply it, etc. So, and we do this n times because we have n elements in the set. So all in all, it's m to n. The second question is, okay, what if we want to consider some kind of subset of the set of all functions? For example, we may try to find the size of a set of all injections from this set to this set. So how many injections f from n to m? And it's also quite easy to see. So note that for the first element, we have m variants to choose. After that, we need to remove the variant we've chosen. And now we have m minus 1 element to assign to the second one. So we need to multiply by m minus 1. After that, we need to remove even this element. So we have m minus 2 elements, etc. And we finish when we assign elements for all n elements. So m minus n plus 1. We denote these like this. A special case of this is when n is equal to m. In this case, we have n times n minus 1 times n minus 2 times times 1, and we call it a factorial of n. And such an injection we call a permutation of n. To choose an injection, f from n to m, we need to choose image of f of size n and distribute image by n. We denote by m choose n the set of all possible ways to choose image of f. In other words, it's a set of all possible subsets of m such that the size of this subset is n. So we denote by the set of all possible ways to choose image of f. And we denote the size of this set by m choose n. Note that there is so many different injections, and it's also equal to the number of ways to distribute image by n, it's n factorial, times the number of ways to choose image, which is equal to m choose n. Hence, we can find the formula for m choose n, which is equal to m lower index n over n factorial. Let's consider the following set. So m choose m choose m minus 1, m choose 0. And note that all of them are disjoint. In other words, they are not intersecting. So if you compute their union, it's equal to the set of all possible subsets. And at the same time, the size of this set is equal to the sum of the sizes of sets. So it's equal to size of the first set, it's m choose m, plus the size of the second set, it's m choose m minus 1, plus plus m choose 0. And it's also equal to the size of this set, which is equal to 2 to the m, which we proved in the first video. In other words, we know that the sum of this is equal to 2 to the m. And we may generalize this, actually, and write the following. If we have x plus y to m, then it's equal to m choose m times x to m times y to 0 plus m choose m minus 1 times x to m minus 1 times y plus plus m choose 0 times x to 0, y to m minus 1. And you may notice that this formula generalizes this formula if we substitute x and y equal to 1. We also may choose n elements out of m. And notice that it's the same number as to choose m minus n elements, because we may choose n elements and keep them, or we can choose n elements and throw them away. So we have this equality. Note that if we need to choose n elements out of m, we may choose or not choose the first element. So there are two cases. If we choose the first element, we now need to choose n minus 1 more out of m minus 1, or we may ignore the first element. In this case, we need to choose n more elements out of m minus 1. So as a result, we have the following equality. In this video, we studied binomial coefficients, and in the next video, we are going to study them further. So if you have any questions about the binomial coefficients, ask them in the comments. See you later.